Alright, and here we're at week 5. We're going to deal with the work van today and continue on with the types of LARs and the main lift umbilical. Right, so here the work vans, RVs, crews, specialized work area. So once again, it's a sea can, right, roughly 8 feet wide, 20 feet long, roughly. Alright, as you can see, it's got identification tags with the weight and all that on it, printed, serial numbers, all the above, right? Everything's traceable. Now you can see here, it's out of the way, ideally not the place to be. Looks like it's lifting straps and all that, so should be all hung up. Okay, so the work van performs the following functions: provides the crew with a climate controlled workspace to safely perform maintenance and repairs. So at least you can go inside and work, you know what I mean, out of the elements. Has a workbench designed for performing repairs, tool preparation and component troubleshooting. Organizes and stores the system testing equipment. Organizes and protects the system tools. Organizes and protects the system spares inventory. Organizes and protects all safety equipment. Organizes and protects all consumables, so your cleaners, paper towels, tire wraps, lubricants, wires, etc. Right, so you got to have all this out there. Right, you got to be self-sufficient contained unit. So here's one view. This is the main door. Alright, coming in. PPE's hung up. Alright, toolbox here. Vice. Electrical components, test equipment. More electrical components. Hydraulics. All of it. You got your dustpan. Alright. This is the other side. Note there's an escape hatch, do not block, and this is in the way. Okay, so that's a no-no. Now the thing about this is, in rough travel, if it's on a ship, be very careful when you open up these. Something might fall out and smack you in the head. Alright, so you got to be diligent and know your surroundings, know your work area. Now that being said about this, every one of these, if this was an oceaneering van, which it is, on every system it should be the same. Does that make sense? So if there's hydraulic fittings in here, and this is mag 33, on mag 55 there should be hydraulic fittings in the same one. Alright, if your spray paints are in here, on mag 33 and mag 55, that's where they should be. Right, if this is where your oscilloscope is, second one from your right, well then, on mag 55, it should be in the same place. Alright, so that's quickness. Okay, so when you're on one system, you know where everything's at. So here's the hydraulic fittings, right? Some of them on one drawer. And this is extremely expensive. Okay, these fittings, especially because they're stainless steel. Right? At least $5,000 worth of hydraulic fittings there, I would say. Easily. So here now you got the... fix this up. You have first aid kit, right? Bloodborne pathogens, eye wash station, earplugs. So you gotta have all that. This gotta be continuously updated, right? You'd be surprised how fast bandages disappear. Now supposedly, this day and age with oil companies on ships and all that, this is all under lock and key, which I'm against. The reason being, they want to record every little incident. Okay, so I'm against that train of thought, and that's just my personal belief. So here you go. Can't get yourself a band-aid. And also there's painkillers in it too, right? Acetaminophen, aspirin, and maybe ibuprofen. So that's all got to be updated because it got expiry dates. So you got your fall arrestor equipment, got to be hung up right. Can't be down the muck, the dirty floors. PPE, your raincoats and all that. Fire extinguisher down here. Maybe it should be on the outside like previously said. Okay. Safety glass cleaning station. So this is what I'm talking about. The work vans where you will spend a lot of time, so keep it clean and organized. Alright? So just be aware when you open this up, something might want to fall out on you, right? So here's a launch and recovery system with a split system. So the TMS, Tether Management System top hat, has been split from the ROV. So this sits on top of that. Okay, so this I can tell you right now is XL38 from out on the Glomar Grand Banks. So I do believe it's retired now. So I worked on this and now we are in possession. The Marine Institute is in possession of the TMS and ROV. The rest of it we do not have, okay? So there's your up to probably a mile long umbilical, armored umbilical, right? This goes into this docking head, right? This bullet latches in, and then this bullet over here latches into the bottom of this TMS. So it's a repeat. There's your tether drum, umbilical drum, okay? 1 mile, 500 meters. Lots of hydraulic equipment, hoses got to be inspected, 14 grease nipples up to, right? Working at heights permit, obviously. Alright, so notice how close you are to the edge of the deck, approximately 80 feet above the sea surface of the sea there, okay? C65 containers, 6'5", right? 6x5. Could be all your other test equipment that's not being, or it could be another third parties, right? So it's a pretty confined workspace, you know. But that's how it is. So obviously you're working out in the elements. So now we got the launch and recovery system, wires and winch. Our work class RV system now has a power, right? We talked about that MG or diesel generator, the control van to control the ROV and TMS to fly. And now we just done the work van to maintain and repair the entire system. We now require some way of launching and recovering the TMS ROV off the deck of the ship or rig or barge or whatever floating craft we are using. But first, in order for the ROV and TMS to be operated from the control van, and in order for the ROV and TMS to be launched and recovered from the vessel of opportunity, and in order for the ROV and TMS to be lowered to and recovered from the seafloor, they need to be connected to the surface. Remember, the electrical lawnmower. The main lift umbilical is an electro-optical mechanical conductor that connects the TMS ROV to the surface winch and is necessary to transfer power and signals to and from the ROV TMS, and is also the strength member used to physically raise the TMS off deck, lower it down many thousands of meters in the sea, and return it to the surface again. We'll delve into the intricacies of the umbilical later on. Okay, so remember electro-optical mechanical. Remember that for future testing purposes. 3 main launch and recovery methods used with several variations of LAR systems available. Over the side of the vessel, no rail or guide wire cursor transition system. Over the side of the vessel utilizing a rail or guide wire cursor transition system. Through a moon pool in the vessel or rig, always utilizing a rail or guide wire cursor transition system. And the fourth way is a fourth and mirror method is when the ROV operates without a TMS and is simply craned over the side and begins operating at the surface from its own tether. These types of systems are called free swimmers. Alright, so know them. Free swimmers are utilized only in shallow water with calm conditions and low currents, since they are directly tethered to the surface vessel and are therefore subject to water currents, surface heave, and are limited in range by the length of the tether on the tether winch drum. Whatever launch and recovery system is utilized will be based upon safety factors, operational functionality, location and height above the waterline, and task duration. For example, a drilling rig operating off the coast of Africa, where the seas are generally calm, would not require a moon pool or lars with guard rails or guard wires. However, if that rig was transferred to the North Sea or off the Grand Banks, the lars system would likely have to be modified to prevent damage to the TMS, ROV, and to the rig. Right, because we're in the North Atlantic and it can get pretty stormy offshore. In my brief 5 years, okay, I was in several hurricanes. I think this day and age they down man to just like a critical crew membership, we'll call it. But when I was out there, it was still full crews. And you could see, 70 plus foot waves, okay? And I'm not lying. On a ship, I was in one, obviously inside the ship, on the Secunda Barents Sea. I do believe it was a 21 meter wave we encountered at one time. Alright, so 21 meters, you can do the math on that. So here we go. As you can see, this can swing as a telescoping boom, right? And sway, right? And it can also rotate. Over the side, no rail or guide wire transition system articulating telescoping lars. So over the side, no rail or guide wire transition system, top hat, articulating docking head, and heave compensating lars. So like I say, hit on the latches, and you just pay out. Pay out on your umbilical, and down it goes. Over the side, no rail or guide wire transition with top hat, docking head, and telescoping boom. So you can see the telescoping boom here, right? And this obviously got a spot where you can, when it's on deck, you can go in here and work. See the little platform? Alright, because like I say, hydraulic hoses with bend radiuses, out exposed in the elements, the cold, the sunlight in particular, right, UV light, and you got several tons that can potentially slam into this. It's not supposed to be slammed in, it's supposed to be a gentle latch, but you get the gist of it once again. So the bolts got to be checked, right, over time, at least once a week, I would think. Over the side with fixed rail cursor transition system. Right, so the cursor is coming down. So this is an extra protection, right? So this is G3. G3 now the Marine Institute has. This was on the Glomar Grand Banks, and for all I know, I could be one of these people here. Alright. This sits on the yellow deck, obviously. You pull in, as in lift up, the ROV and TMS. So this is a cage TMS, obviously, right? The ROV's inside in the cursor wire, cursor transition system. Anyway, you'd lift up, 6 inches, and then open up your trap doors, more or less, and down it goes on these guide wires here. Alright, so that's where you would be, the winch operator would be up here, okay? Up here is the control van, work van, winch operator would be out here. Moon pool rail guide cursor transition system. So now moon pool's like in farther, like this is on the outside of the rig, more or less, okay? And this would be on the inner part on the deck or ship. Alright, same thing, this opens up, you lift up, and this opens up. Right, interior moon pool with rail guide cursor transition system. This reminds me of the Eric Roud for some reason. The good thing about Eric Roud was that you were inside. The moon pool was. So you could work. The bad was these fans would suck in exhaust from the rig. So you had to just think I'm working in a garage with the doors closed, with the motors running, okay? And it could be that dirty. So interior movable rail guided cursor. Now you can see these slots, right? Sometimes there's joints in these slots, and this cursor system can get cocked and caught up in it. You'd literally, well, worst case scenario, you'd have to get rope access technicians, rats, okay? There's these guys that can work at heights and, you know, like scaffolders in a more mountain climbing way. A lot of times you'd get the heaviest maul, tether the maul, and drop it and knock it free. Okay, maul as being a persuader or sledgehammer. Okay, whatever you want to call it. Persuader is the name I like. So this is a free swimmer. Alright, so the tether drums right here. Note the absence of TMS and umbilical. The ROV tether is paid out from the deck winch. The ROV is therefore free swimming as soon as it enters the water. Advantages of wire guided or rail transition cursor systems. Know this. Systems can be launched and recovered in rougher sea conditions than non-guided or free swimming systems. Less likelihood of damage or loss due to uncontrolled swinging and collision with lyres, hull or other structures. Less likelihood of damage due to air-water interface motions. Disadvantage: more expensive to install, more complex to operate and to maintain. The winch must be powerful enough to lower and raise the weight of the TMS ROV combination up to 6,000 kilograms. Alright, so not 6,000 pounds, 6,000 kilograms. It must be powerful enough to lift the in-water weight of the umbilical. 4,000 meters of umbilical weighing 3.63 kilograms will equal 14,520 kilograms. The winch must therefore be powerful enough to lift a static load of at least 20,520 kilograms, but is rated for a similar dynamic load, plus be able to break and hold this weight at maximum depth. The umbilical must therefore be rated for the safe working load of the complete system, including the weight of the TMS, the RV, and the full length of the umbilical paid out. So here's your winch. Alright. Now all these got these control access panels. Alright. Take it from me. On a rig, they're pretty watertight. On a ship going through 18 to 20, 21 meter seas every now and then, water will find its way in there. Okay? So your job as a technician is to continuously monitor inside here. Other than that, you don't get in these cans too much, okay? Or termination boxes, whatever you want to call them. There's various names you'll hear me say. Now, the winch has its own hydraulic power supply called HPU, so the hydraulic power unit. Okay, you'll hear APU, that's the auxiliary power unit, to run the thrusters and all that on deck for the ROV instead of using its own motors, because motors on the ROV are water cooled, so you can't run them for long. So you use the APU, but this is the HPU, right? It powers the winch, and it powers the hydraulics for the lyres, rams, and motors. That's the actuators, right, the rams. The winch and lyres controls are typically located on top of the winch to save space and for the operator to view the winch drum and level one when paying in or out. So the HPU houses a 200 horsepower electric motor that typically runs two hydraulic pumps connected together, the main pump powering the winch. The second hydraulic pump powers the lyres, launch and recovery system, hydraulic rams, and motors. Okay, so once again, you got to be diligent. This is laid here, wrapped up, these hydraulic hoses, right? Probably lying in filth. Subject to the exposure of the elements, sunlight, whatever. So you got to bend the knee, I call it, bend the knee, and pick and probe, lift, inspect, okay? You don't want these busting out on you. This got to be covered. Alright, this is the line of controls. So the winch operator stands here and he's under command of the deck officer, okay? That's the guy who's going to tell him what to do. So haul in is paying in, paying out is obviously paying out, going out towards the sea, okay? Emergency stop to right. Winch and lyres controls are usually located on top of the winch to save space and for the operator to have a good overall view. the layer of the layers assembly, the winch drum, and the level on when paying in or out. The winch is powered by one large hydraulic motor that turns a gearbox with payout speeds of approximately 30 meters a minute. Hydraulic actuated fail-safe brake is incorporated into the winch drum. Right, so when you stop paying out, the brake is on. The brake is constantly on. Okay, you overcome the brake by paying out. Okay. Winches come in all sizes and configurations. This winch is a Dynacon model. That's what I dealt with. M421 with a straight line level 1 system. This type of winch would be used for diving operations down to about 6,000 feet of seawater. Alright. So there's your stationary junction box, right? The slip rings are inside where this is at. Goes straight on through. And your winch rotating box, okay? The winch is configured with a 90-degree level. This winch, okay, 90-degree level 1. That's this here, sorry. So it comes out and then makes a 90-degree turn. Does that make sense? Straight out to this makes a 90-degree turn. Right, going that way to your right. The winch is configured with a 90-degree level 1 system that permits the winch to be secured sideways and closer to the larger system, effectively reducing the overall size of the system footprint. This design also maintains a steady angle between the winch sheave and overboarding sheave, preventing umbilical wear and damage caused by excess fleet angles. This is a Dynacon 5521 XL traction winch used with systems that operate in water greater than 5,000 feet, where line pulls between 25 to 50% of umbilical braking force. Haul line pulls from increased weight of the system plus long lengths of umbilical tend to knife or bury the outer layer of wire rope in the previous layers of umbilical on normal drum winches, causing wear and damage. The modern traction winch prevents this type of damage. The traction unit can be easily added to any 521 XL 521, which has a 90-degree level 1. So what they're talking about, if you don't have constant tension on this as you're paying out, if you don't eyeball, it's quite the artwork to launch this ROV. Alright, newer models got, like, you know, tensioners that can make a correct tautness on your umbilical, but you would have to have just a lazy sag, not too much tension because you're straining everything. Too much of a sag as you're paying out, these wraps become loose and the underlying wraps become loose, and the top outermost wrap can get wedged in between. That's what they're talking about. Knifing, horrendous, painful to fix, okay? So it's quite the artwork it used to be to launch these. So capstans, right? In a modern high-tension traction winch, the umbilical is reeved over 2 independently powered cantilever sheaves with 6 screws. Friction between the umbilical and the sheave grooves provide the traction to provide high line pull without damaging the umbilical, as in the case when the umbilical is wound onto a standard drum under high load. The winch drum on this type of winch is typically referred to as a low tension storage drum, not a line pull drum, since it only exerts about 10% of the normal tension and its main function is to store the umbilical. Now that being said, down on the Scandi Vinland, the new UHD, from what I could see, you didn't see the layers. It was like behind closed doors, and it had a 5-ton tensioner, so it was almost like maintenance free. But I can't say that because it's a moving machine, so moving equipment is going to break down eventually, okay? The winch drum, or an traction winch, is typically referred to as a low tension storage drum and not a line pull drum, since it only a fraction of the normal tension. It is only a fraction of the normal tension, and its main function is to store the umbilical with no risk of knifing damage due to high tension. Alright, so this is, you know, beyond perfect. Notice the wet look. That's how the umbilical's got to look. But like what I'm saying, this here, right, could get wedged in 2 to 3 down if you do not have the right amount of tension as you're paying off. And like I say, it only comes with trial and error. You gotta do it. Maybe 1 or 2 screw ups before you get it down pat. Maybe you might get it the first time, but it's not the easiest to do. Okay, it's artwork, we'll say, more than science. So now we have a power. We have power, a surface handling system, and an umbilical. Let us review the 480 VAC power flow path from the PDU to the subsea motors. Right, so power distribution unit. Alright, so you got your contactors up here. Right, cage motor. Port and starboard of the ROV into your stationary junction box, which I just showed you. Up into your winch transformer can. Now this is a different model. Usually transformers nowadays are up in the PDU, okay? Back into your stationary, through your slip rings, out through your umbilical, or through your rotating junction box. Alright, so this is now where it ends for the surface, obviously, right? Umbilical, into your cage termination can, straight into your cage motor, into your cage slip rings, cage rotating can, your flying tether, into your vehicle termination can, starboard motor, port motor. So here's inside of a PDU again. The contactors burnt the 3-phase 480 VAC power into the flow into the deck leads going to the stationary junction box on the winch. So the motor 3-phase AC power and the TMS ROV single-phase AC power must travel from the PDU down to the TMS and ROV. Try to think of this pathway as a series of electrical power cords that must be joined together in order to ultimately reach their goals. Each power cord is a separate part of the pathway and must be connected to the next power cord by use of a termination strip or other type of high voltage, high current rated connector. Alright, so here's your termination strip, right? Black on this side, black coming off on that side, same gauge of wire. We'll say number 1. Blue, number 2. Blue, number 2 going off. Okay, so that's how you would wire this up. Orange, number 3. Orange come off, number 3. Same gauge of wire, okay? So make sure you keep industry standards, we'll call it. Now, an interesting fact that I seen once upon a time in a stationary junction box on a cage on the Secunda with mag 14. This was at the bottom of the can, obviously, right, the termination box, and there was water. Now these are oil filled cans, so oil being lighter than water, right, so the water was in the bottom of the can, and these separators were after being broke off, so there was like a droplet of water. Alright, and it was migrating. It was a ghost snag, we'll call it. It used to appear and disappear and would trip out the circuit breakers, okay? Limb out. She would limb out on us. But it only happened with the certain rocking of the ocean. So what it was, we deduced finally after wringing out the system, draining all the cans, there was water in the bottom. And depending on the pitch and roll of the ship, the water would, you know, go from number 1 to number 2 or whatever. From 1, 2, and 3, making a conductive path. Okay? So that took like a day and a half to find that. So some of your snags, that's an aircraft term, as in trouble, okay? Your snags are hard to find. So motor flow again, let's say the PDU is located 50 meters away from the winch. The power deck leads would have to be at least 50 meters long, plus a few meters on either side to reach the junction boxes. Now let's say the system was moved to a rig where the PDU had to be located 100 meters away from the winch. You could not use the 50 meter long deck leads you would need to order new leads. This is the reason most systems have long deck leads that can be called up when total length is not required. So you're going to call them up, you're going to find some type of hook on a wall somewhere or underneath the winch on the inside. Alright, you're not going to try to lay it down on the deck. So once again, Subsea motor power flow. Alright, the 3-phase 480 VAC motor and the 1-phase 1400 VAC power conductors are routed from the PDU inside the control van to the stationary junction box on the winch. So remember now, our rocks blocks. Alright, this is not what they're talking about. It will be these bigger ones, obviously, right? The voltage, you're not going to put the 1400 down through this, obviously. Now here we go, stationary junction box. Okay, slip rings in here. And that looks like the rotating, okay, that silver one there. Deck leads from the EU, enter the stationary junction box, so it's going up inside, okay? Now this is pretty neat, winch stationary junction box. Okay, so let's just move this over. And we got the 13 power waters, 9 by the 3000, 4 by the 1400 VAC. Right, so the 3000 be 3-phase, 1400 the single phase, okay? And twisted quads and fiber optic lines going to the slip ring assembly. Incoming high voltage 3-phase. Incoming fiber optic lines and low voltage twisted quad wires. So you can see the nice neatness there, right? So this is obviously dealing with a step-up transformer where it's outside the PDU. Alright. So they are on older systems. Like I say, inside the PDU is where usually your transformers are at now, from what I know of anyway, from what I've dealt with. I have seen this before, but only once or twice, okay? Fiber optics, got to be separate, okay, from your cabling. So what you got to have is nice bend radiuses. If it's tie wrapped, you got to be flush cut, so when you're sticking your hand in, you don't cut your hands on the jagged pieces. Screwed in tight, give it a tug test, right? Not to rip it out, but you know, a good little tug test, 10-15 pounds tug force. It shouldn't be moving. Make sure you pick up your screwdriver afterwards, okay? And most important, lockout tagout procedure before you go into this box, so there's no live voltages in her, okay? So this is the outside winch transformer can, the coffin, right? Where the motor 3-phase 480 is power stepped up only to about 2300 to 3000 VAC. So like I'm saying, now that's inside the PDU, okay, in the control van, from what I've seen. Maybe they've gone back to this configuration again. So here's the slip ring. Now, with the slip rings, you're more or less responsible for the wiring going into it. You don't touch the inside of the slip ring, from what I know. You take it out and disconnect and put in a brand new one. Okay, so you're a parts changer. So these are pretty complex. So slip ring is a rotary coupling that transfers electric power and signals from a stationary to a rotating unit. This is a close-up of a mechanical slip ring assembly where the rings are stationary with the winch and the carbon brushes and housing shown here rotate around the ring assembly. There's also a fiber optic slip ring attached to the electrical assembly. Now, I was to a seminar one time and they were showing slip rings a lot smaller than what's on work class, probably like 18 inches long. So they had a pure copper one, $6,000, and one same size with fiber optics, $60,000. So that's the difference, alright, when you got the fiber optics. So the winch rotating, you know, junction box from the slip rings to umbilical, okay? So this is now, after this, it's the umbilical, which is subsea, we'll say, okay? Note the fiber optic and twisted quad data signal wires are connected inside here. Slip rings conductors connected to the umbilical conductors at high voltage term strips. So as you can see, all nice and neat, right? And this is all inside the this is how it's manufactured inside the armored umbilical. See how it's all twisted? So obviously with the twisting, if you had a mile of umbilical, it's a lot more than a mile of wiring inside because of the twisting, right? Once again, the power is sent to the TMSRV through up to 4,000 meters of opto-electromechanical umbilical. So there you've seen that twice. Okay, know that term. And then it's potted. Alright, so once it gets to the TMS, you cut off the armor. Alright, and you pot it with wire lock. The conductor bundle passes through the bullet and is turned into the TMS termination box. So the TMS bullet is then bolted onto the TMS frame, permitting the TMS ROV to be lifted. Alright, so there it is coming down, right? Off the deck and lowered to operating depth. Note the unarmored umbilical conductor passing through the bullet, where it will be routed through the TMS framework and enter into the TMS termination box. So the boys got their fall arresters on. Okay. Subsea motor power flow. The umbilical passes into the TMS turn box, as this is the end of the line for the umbilical. Power and signal wires will be terminated in this box and will continue onto their respective motors, transformers, and fiber optic multiplexers. This box will be sealed and filled with oil and pressure compensated to keep water out. More on this later. Alright, so it's coming in. You can see it coming in here, okay? This was the armored umbilical, but once it hit the bullet, you cut the armor off. So it's almost like a tether now, alright, underneath. Coming in, coming out here. So he's got lots of excess wire coming out. And this guy is going to cut these to length and put whatever number corresponds in color, right? Like whatever color corresponds to number 1 term strip with the number 1 position, right? If it's black, brown, yellow, orange, whatever the manufacturer says, okay? And he's just going to cut it to length and terminate it. And this is an oil-filled box, right? You can see the O-ring here. O-rings, right? Groove. And many, many bolt holes for your screws / bolts. So TMS and ROV require single-phase AC electricity to pass, just like the 3-phase AC power required for the subsea motors. The single-phase voltage must be stepped up before it begins its long journey through the umbilical. The voltage is stepped up inside the control van and then follows the same path as the motor power down the umbilical to the subsea transformers and onward to the survey and electronic pods on the TMS and ROV. So this is the electric flow now, right? So once again, from breaker 1, right, up in your control van, motor generator van, down through, following through your cage electric contactors, vehicle electric contactors, stationary, junction box, winch, slip rings, rotating. Then you got your umbilical, coming in your cage umbilical term can, right, being stepped down to your 120, okay, for the electrics on the cage. Continuing on, it was the 1400 for your vehicle, so it's going to go through the drum, rotating tether cam, right, out. Then as you're flying tether into your vehicle term can and hitting your vehicle transformer, being stepped down to the 120. Okay, so once upon a time it was 460, 480, got stepped up to 1400 and gets stepped down to 120. An alternative to running a large MG unit which provides clean 1-phase or single-phase and 3-phase power is the use of a mini MG unit housed in the cabinet within the control van, which cleans only the single-phase power going to the TMS and ROV electrics. The dirty 3-phase TMS ROV motor power continues directly from the platform power supply into the PDU, where it continues down the usual power flow path. So you got your 3-phase dirty power, right, going straight on through, as you can see, to your motors, and MG is going to clean up, right, the single phase 1400, alright, for your electrics, TMS electrics, ROV electrics. Alright, so that's it. Hopefully these little black diagrams are after helping you understand. Right, it's important that you know the black diagrams and where they correspond to on the vehicles, right? And the TMS. Am I making myself clear? Right, you want to know where to go. Alright, so this is winch rotating junction box. Okay, up on, so you should know that there's 1400 and 3000 volts here, obviously, okay? And if there's a 8 gauge and a 10 gauge, the 8 gauge is a bigger gauge wire, that's going to be for your motors. The 10 gauge, next one down, is going to be for your single phase, right? Just little things like that to know in life. Alright, so that's it. And signing off for the day, for this week, week 5.